Hi, my name is Tyler, and I'm going to talk a little bit about the quadratic formula. Let's start by asking, what is a quadratic equation? I can start by giving you an example. One quadratic equation is 3x squared is equal to 2 plus 2x squared. The question is, what value or values of x solve this equation? In general, a quadratic equation is a polynomial equation of degree 2. So by saying it's a polynomial equation of degree 2, I mean that you can use x squared terms or x terms or constant terms, coefficients times 1 instead of the variable x, but you can't use variables x cubed, the square root of x, or higher degree terms. One property of the quadratic equation, of any quadratic equation, is that you can always simplify it to a certain form, and that form is ax squared plus bx plus c is equal to 0. And the main question that we're going to ask about this type of equation is, how do you solve for x in an equation of this form, ax squared plus bx plus c is equal to 0? That's the main question. Let's take one more look at this example to check that we can simplify it into the form given here. If I subtract 2x squared from both sides, I have x squared is equal to 2, and then I can subtract 2 from both sides. X squared minus 2 is equal to 0. So I can think of that as a is equal to 1, b is equal to 0, because it's sort of like I'm adding 0 times x, because there's no x term, and then c is equal to negative 2. By the way, you might wonder why a quadratic equation starts with the prefix quad, which sounds like it means 4 when it's really a second-degree equation. Well, if you think about it, x squared is the area of a square side x, so we sometimes associate x squared with squares, and so that's why the quad prefix makes sense for quadratic equations. Okay, now I'm going to tell you about a really cool game called the quadratic equation game. The way this game works is one person thinks of a quadratic equation, and then they tell the other person. If the second person can figure out the solutions, then they win. But if not, the first person wins. And we're going to play this game. The first equation I'm going to give you is the one that I started with, which is 3x squared is equal to 2 minus 2x plus 2x squared. We saw that we can simplify this to x squared is equal to 2, and now it's not too hard to say, let's take the square root, and we'll get x is equal to the square root of 2. Okay, great, we found a solution. Is that the whole answer? We'll find out at the end of the lesson. Okay, let's try another one. Second game. Let's say I give you the quadratic equation x squared minus x minus 1 is equal to 2 plus x. Okay, right away you'll say, hey, that's not in the form ax squared plus bx plus c equals 0. We can fix that. Let's subtract 2 and x from both sides of the equation, and I'll have x squared minus 2x minus 3 is equal to 0. If we take a look at this equation, you might realize that we can actually factor the polynomial. This is the same thing as x minus 3 times x plus 1 is equal to 0. Once we factored it in such a nice way, we can see that the solutions are going to be x is equal to 3 and x is equal to negative 1. If you want to check your answer, you can plug in x equal to 3 into both sides of the original equation to see what you come up with. Let's say it's 9, minus 3 is 6, minus 1 is 5 on this side, and then we have 2 plus 3 is also 5, so it works out. It might be a good idea to check the other solution just to be sure. Okay, great. We solved that one. Good job. Second player wins. Let's play one more game. The next equation I'll give you is equation C, 2x squared minus 8x plus 10 is equal to 0. Well, I noticed that I can divide by 2 at least. That simplifies the equation a little bit. X squared minus 4x plus 5 is equal to 0. Well, factoring worked last time. Can we factor this guy? If you pause the video and spend some time trying to do it, you might see that it's actually kind of tricky. So for right now, let's say that we can't solve this one. Okay, eventually we'll come back to it. I want to mention one more idea that has to do with a quadratic equation. I'll call this D, even though it's not obviously a quadratic equation at first sight. What I'm going to draw is a rectangle that's in approximately the golden ratio. The golden ratio has the property that when I draw a square inside a rectangle with the correct shape, the interior rectangle has the same shape as the overall rectangle. Now that might be a little bit vague, so let me try and fill in some details for you. Let's pretend like the side length here is 1, and the width of the rectangle from left to right, let's call it x, and we want to make sure that this ratio, x to 1, is the same as the ratio of this smaller rectangle here, 1 to x minus 1. The way I know this is x minus 1 is that this is a square. Okay, that's the defining property of the number x. Let me repeat that just to make sure it's clear. The ratio of this width, x, to the height, 1, of the big rectangle is the same as that between this width here, x minus 1, and the height here, 1. I can write that as an equation. X over 1 is equal to 1 over x minus 1. It's not obvious that that's a quadratic equation. In fact, right now it's technically not a quadratic equation, but I can multiply both sides by x minus 1, and I get x times x minus 1 is equal to 1. If I multiply out the x, I'll have x squared minus x is equal to 1. And in fact, I can subtract 1 from both sides. I'll have x squared minus x minus 1 is equal to 0. Suddenly, I do have a quadratic equation, and if I could solve this quadratic equation, I know exactly how long this rectangle would have to be in order to achieve the golden ratio.